All right. So today we're going to be doing the initial setup tests and benching a 42. I do this with every single one of my builds. It's a good practice just because it prevents you from dealing with problems later on down the road. One thing that I don't like dealing with is when you get the whole keyboard together, if you're testing it after it's fully assembled, it's a lot more difficult to diagnose issues. So it's just better to kind of follow these steps. So let's get started. I'm gonna move some stuff out of the way because I don't have a huge desk. So stick with me here, but let's see if I can get some room here. So the first thing that you wanna do when these Pro Micros come in, and by the way, these instructions are just solely for kits. So these Pro Micros are not programmed from the manufacturer. So they have a slightly different flashing approach than what you're going to have after they have the QMK Vial firmware on there. So to do that, effectively what we're going to do is we're going to plug in each microcontroller. It's going to start flashing. You're going to hold both and then release one. See, that was the wrong side. It doesn't matter. Release the other and then release that. So once you do that, that should put it into a drive mode, and we'll go ahead and mount and open that. And I'll drag the correct firmware on top of it. It just acts as a USB drive. So now this is operating as the keyboard always will. So if I double click this, it goes into drive mode. I said double click, but you know what I mean. So that puts it into this kind of mode. So knowing that, this is accepting it. I can see on my computer that it's registering as a keyboard. This is the exact same step. Hold both, release the right, release the left. You're gonna get a notice that it's trying to be a drive. Mount it as a drive. Drop the firmware in. All right. Once it automatically disconnects as a drive, it should be recognized as a keyboard. If you double tap the right side, it goes into bootloader mode and will show up again as a keyboard. So that's the first test. The first test is important because one, you want to make sure that these things are good out of the box. Now for the second part. The second portion that we want to get over is dun, 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 dun. All right, sorry about that. I will solder up both of these sides because the next test that I want to do after I'm done making sure that the MCUs actually work is I want to make sure that the sides communicate with each other. The easiest way to do that is to begin soldering. So I'm going to turn on my noisy fan. Apologies for that. And we'll get soldering. I like to put just a single tack down first. Then to make sure that the MCU fits on there nicely with a single tack, which is kind of nice. Because if you've made any mistakes up to this point, you can just heat up that single tack. It gets a lot harder when you have more than one. Let me make this a little bit bigger here. There we go. And those pins wiggled around just a little bit, so I just want to make sure that we're still good. That is still a good fit. I like to skip around, that way I'm not loading a bunch of heat into the board. In the same spot. Okay, the grounds are a lot less fun, but I find if you just do you load them up really quickly and then go to the other side and put heat, it helps spread it evenly. I did update the thermal reliefs on the latest round that's coming in. And just because these grounds have been kind of challenging to solder. There we go. It's always a compromise between a really good ground and good solder ability with those thermal reliefs. You can see the solder doesn't really want to stick. That's a lot better right there. There we go. There we go. Same sort of situation with these. Do not spend a lot of time heating up the same exact spot. Try to go relatively quickly. But you have to watch for it to absorb into the hole, which you can see right there. And then I'm going to move to a different part, that way I'm not building up tons of heat in the board. And I have coffee hands. You can see that went in. I'm going to come back here. I'm not loading up the board with tons of heat. I'm just waiting to where I can see like there's kind of like a suction action where you can see it pull it down into the pins. If you're an experienced solderer, please ignore this, but if you're an experienced solderer, you probably have the magic hands that hold stuff for you, which is something I need to do, but I don't mind a little bit of wiggle here. So there we go. Get the tip clear. Okay. See how nice those are? Like little slightly melted Hershey Kisses. Not really sitting super high above the pin, just kind of sitting in it. I'm not holding a lot of heat in one spot for a long time either. Super important on these things. Some of the components are really close to the pins. This is also interesting too because I'm using the OBS screen for this, so there's a little bit of delay between my a little bit of a delay between my setup and what's going on the screen. So it's kind of like trying to talk with your mouth slightly out of sync. All right. So you can see the little action in there once it draws it in just slightly. It's a little bit harder to see without a microscope, but you can see how like some of these, like that little component right there is super close. This little guy right here, that resistor or capacitor right there, probably capacitor, but is so close to that pin there. Like you don't want to overload this stuff with too much heat. There's a little bit of a capillary, I don't know if we call it capillary action, there we go. And that's the crystal oscillator right there that I'm soldering next to. Okay, let me tackle the one by this little tiny baby resistor. Alright, that looks pretty good. And then we just plug it in to make sure that it registers as a keyboard still. I'm on Linux, so I just check the journal. Okay. It's still a keyboard. So that's one side. Now let's do the next. Same instructions as the last side. I like to just tack these two little bottoms and check alignment before I continue. See how those kind of pick up a little bit sometimes? I'll just put my finger on them and then touch here. Touch the pin, let it lay flat. Touch the other pin, let it lay flat. Next thing I want to do is just make sure that these things still are in pretty good alignment with the MCU. That's pretty good alignment. Alright, so there's a lot of wiring on this side. I've never ran into issues where the trackball won't work, but I will try to, when I'm putting heat, there's always like a little bit of ambient heat put off by which side of the iron you're using, so I'll tend to shy away from where I can see there's a lot of signal going. So I will tack up here to kind of get a little bit more stability in place. And I'll also tack up here. All right. Paranoia, OCD. I will check the MCU again. Probably looking at it, there we go. Yeah, that's a pretty good fit. Again, not really putting heat in the same spot, jumping around the board. That way I'm not overheating any particular section of the PCB. If you're moving good enough, or maybe if your iron's not blazing hot, you could probably just go sequentially through the pins, but I just kind of like to randomize it a little bit so I know that I'm at least dissipating some of the heat instead of concentrating it in one area. Like I said, a lot of this is just heat management, and I've been doing a lot of support, and a lot of the support is cooked boards, so that's why I'm turning this build into kind of like how I do my builds for bench testing. I am an unlucky person in general when it comes to like faults and stuff like that, so you don't have to be this paranoid if you're naturally lucky, but I just run into this all the time, and it's just because it's kind of like a Murphy's Law thing for me. Like, if it's gonna go wrong, it's gonna go wrong while I'm doing it, so okay. Again, I like to kind of leave my ground pins for last. I have some new boards coming in on Monday that have different thermal reliefs, so it will make the ground planes a lot easier to solder, and that'll help with this whole kind of like making sure that heat isn't building up when you're soldering. I'm soldering at 320C, which is what my solder manufacturer recommends. So that's also important. You want to be soldering at the temp for your solder, for your manufactured solder rate. Like, even if you bought like an Amazon solder or something like that, like, you need to be paying attention to the temperature. It's kind of like if you're into 3D printing, the you know, not all PLAs are created the same, because you have leaded solder, you have lead-free solder, so like a one size fits all for your gun, for your soldering iron is like it's not the correct approach. All your manufacturers suggested temperature there. This one is Kester. It comes kind of highly recommended by the soldering community if you want to do lead-free, no clean. Which is nice because sometimes when you leave the residue behind, it can eat away at things. So you can see how these are all looking like, even though the pins are really long, which gives it an elongated look, they're all kind of looking like as if you set a Hershey Kiss and let it melt down a little bit. And you can see the little suction effect there, like once it's hot enough to draw in. Again, the go-to with these grounds is I just load them up quite a bit because they dissipate heat really easy. So it's just easier for me to kind of load up the tip. With what you would consider to be way too much solder, but it's kind of nice for that. So I'll hold it there. Yeah, you see that it's still drawing in. That's pretty good. That little pad's being a punk. That's okay. I've got patience. Yeah, hot swaps for the MCU is a nice one. That ground pad hates me. Let's see if I can draw it over here. Don't you dare bridge. So there's a little bit of a bridge here. There we go. And it's only these bottom pads that are a big pain in the butt. But I like to, again, the reason why I do the pins on this, like it pulled it completely off. The reason why I just do the pins in the beginning is because if I tacked on and then flipped over to the side and put the MCUs on and then continued my welding, the problem with that is that I would be loading, like I'm putting some pretty good heat into this ground plane right now, and I would be loading the MCU with that, and that ups the fault rate. So I don't want to be doing that. But now we can tack on the MCU. Ta-da! And we'll go through and do this. Again, my MO is skipping around on the pins. I don't want to load heat into this board. Much like real welding, too little heat, you don't get a good connection, you don't get good bonding. Too much heat, welding, you burn a hole through things. Soldering, you cook components, and then stuff just does not work. It's a RP2040 which is a very popular MCU for chips, but it is made by the Raspberry Pi Foundation. I think it's the chip that's in the Pi Zero, stuff like that, but yeah. So you can see how that sits there. You can tell when it goes into the pin because it'll kind of go all the way around, and then it still has a sheen to it after it dries, so it's not like not a dry or cold joint. And again, I'm just moving around the board with my shaky coffee hands to make sure that I'm not building up tons of heat in my MCU in the same exact spot. I'm working to distribute the heat. I don't know if my hands, I feel like they're very shaky right now, but see how this one didn't, this one almost went all the way around there. I need to get those magic hands. Just haven't gotten around to it. There's something challenging about stuff wiggling around if you don't have steady hands too, so. Notice how close that little tiny component is to that pin. That was my least favorite pin. These two are a little rough. You can't put too much heat. You can't put too much heat into these. It's oh. Alright, I'll get this one out of the way because I'm not a fan of it. Alright. Oh, yeah. And you know what? I'll get one of the twins out of the way here. There we go. Nice. We're almost out of the woods here. It's a little bit too much on that one. That's okay. The nice part about the grounds is that it's triple redundancy on that one. There's 3 pins going to ground, so like, yeah, you have to put more heat in them, but there's not a lot of voltage, and there's definitely not a lot of amperage going through these little boards, so it's a little more forgiving with that. That said, you know, the next revision of these boards has way better thermal reliefs. Do you mean flux? This has flux in the core, so it's kind of auto fluxing. There's a lot of YouTube shorts. There's this one guy that does Yeah, the flux doesn't help on the ground plane ones just because it's with the ground plane without any thermal reliefs, it's so good at dissipating heat that you effectively just have to superheat the entire area. Um, and it's funny because like when you hear thermal reliefs, it's like, oh, it's kind of like to get away heat. But the thermal reliefs in PCB design is actually there to contain heat in an area. So yeah, I don't know why they call them thermal reliefs, but anyways, at this point, we have both of these guys connected. It'd probably be good if I'm going to take a look at my solder joints. See, all those look pretty good. All of these look pretty good. One of the important things that you'll notice, and it's kind of a hint, is when you have like horrifically discolored flux around a pin, you probably got stuff too hot. And you can see there's no like discoloration around it, this kind of stuff. There's no like melting of the numbers. I've been seeing a lot of pictures where, you know, you can see that the graphics are started kind to morph, and you can see there's still like the surface of this is all still very smooth. That's the other one that I'll notice too, is like the bubbling up. Like if you're bubbling up the silk screen, you put way too much heat into this. So let me switch. I think we can kind of be done with this, but let me try to awkwardly move it out of the way without killing the camera. All right, so the next thing that we want to do for the bench test, we want to test that there's good communication between the sides. This is something that is usually tested after the board is completely assembled. Again, I do not recommend that. I recommend doing it like this. This is before I've even soldered on sockets on any of this kind of stuff. This is just, let's make sure this thing acts as a keyboard, and I'll show you too how to do that. So ribbon strip, blue side goes up, make sure that it's seated in there nice. The clamshell, you can feel it kind of go back, and then the clamshell should feel kind of difficult to close. Open up the clamshell here, insert, sorry, make sure that that's like that. And then I'll place these like this. And the reason for that will make sense in a little bit, because what I'm going to do is I'm going to connect the halves, and then I'm going to short these. Really easy to short when, you know, even if you did spend the time to solder up the individual little hot swap sockets, it's easier to test right now. This is like what I would call a bench test. Yeah, it's for a keyboard. Very alien looking, not traditional split keyboard. Beautiful. Okay, so now what we want to do is now have a nice little bar going through. There we go. This is the question that comes up all the time too. I thought the directions were pretty clear with it, so I apologize if it's not. But you are going to have a magnetic USB-C cable, you're going to have two of them provided for you. So there is a magnetic dongle side, and then there's the traditional side. For connecting the halves, you go bottom USB, not the magnetic one on this side, to bottom on this side. It would be nice if I didn't put those completely in the way. Now, assuming that these are all positioned correctly on the screen to where you can see them. Let's see, there we go. Oh man, go to sleep. All right, now for the fun part. We should have a keyboard. I have a keyboard tester open here, and what I'm going to do is click. And you can see that we have live here. I just kind of go through. And then on this side, you can see we have life over here. So yeah. Ta-da! So that is a bench test. And this is the thing that you want to do to make sure that your keyboard works before you go through the grief of installing everything. Because this is where it's like, oh, this side's not working. And you're like, okay, well, how? And then the way this works is, does this side work? If this side works and you give it that test, then it is either the data pin got way too hot and it was cooked and it is no longer conductive, the resistance is too high. You can test that with a multimeter. It's really easy to tell what the data pin is. I'm wondering if I can give you an example using the microscope here. All right, so all right. It's pretty easy to tell that. Let me see if I can get this pin right here, which is 1, 2, 3, 4, 5, 6 down on this side is the data pin. So QMK requires symmetry on the boards, so pinouts have to be the same unless you introduce hacks. So the 6th pin down on the left side, because this board's upside down right now, is the data pin. If you're not getting communication from here to here, the data pin could be cooked. You could be using the wrong type of cable, or this MCU could be cooked. Okay, so if we know that the data pin isn't cooked, there's no weird resistance going from pin 6 to pin 6 through the cable, then and tested with a multimeter, and you know that this MCU, when you unplug it and you plug it in over here, everything works on that side. Usually it means that like this pin has been cooked from here. So it's kind of like, this is the main power. It goes over the wire, comes in through that pin, no resistance on that pin as tested, then maybe this MCU is cooked. If this MCU is actually completely cooked, when you plug it in, it shouldn't respond as a keyboard. It will respond as a keyboard if it's good. That could mean solder joints are bad. There's a lot of other things, but like pin to pin, you should be able to test that kind of stuff. The next one is, I have a key that's bad. And this is pretty easy. If it's, let's pretend for a second that this is the key that's bad. the way keyboards are wired up is they're wired up in a matrix. So like this is, you know, column 0, column 1, column 2, column 3, column 4, column 5, and the same exact thing on the other side. So if you have an entire column that's not working, that's kind of similar diagnosis. You start at the pin here. Make sure your joints look really good. I tried to show you what good joints look like. And then what'll happen is if this switch has a bad connection, this one won't work, this one won't work. And if this one has a bad connection, this one won't work and that one won't work. That's like a columnar failure, which is pretty easy to test. Like you can just fix the joints here, fix the joints here. It's probably not if you have a column failure on a crosses or bridges kit, it's most likely you're soldering on the MCU, because these are all PCBA. Like these are 0403 size components, I think. No, these are 0608. I can't remember. These are the most popular SMD resistors for keyboard matrices, but I didn't want people to have to deal with that, because I've put so many of these things together that I want to put together a keyboard in like about an hour start to finish. I don't want to be doing this like an all-day project. I've had so many keyboards where I'm fiddling around with these little things and just testing little dead circuits and stuff like that, that I didn't want to deal with it. So all the kits from me come with like the PCBA, and all you have to do is solder the MCUs and the hot swap sockets, and that's it. Makes it a lot easier. If you have OLEDs, you have to solder the OLEDs, but not a lot of joints to deal with. And that's kind of fundamentally it. You know, the other litmus test is if you plug it in and you have OLEDs, which you should have bench tested this way first, but heaven forbid you have the OLEDs completely connected. If you plug it in and the logo is right on both sides, and then you move the plug to the other top keyboard and then they're both upside down, that means that they're registering with each other, and that's totally normal behavior. Yeah, very big pain with shaky hands. But this keyboard is essentially like, right now, since I have bench tested it, I can assert that I can comfortably assemble this keyboard, and by assemble I mean start soldering up all the individual little hot swap sockets. And if a key doesn't work or a column doesn't work, well, a column's probably not going to fail on you, but if a key doesn't work, I know it is the new joints. It's the joints in the next step. It's not start from scratch. So it's much like you're building on knowledge as you build this keyboard. And I recommend doing that for every keyboard kit. The hardest thing you can do is assemble the entire thing, and if anything goes wrong, you're like, where do I start? So that was kind of like, I'm doing a keyboard build right now for a gentleman in Japan. I don't know why. I'm kind of a big deal in Japan. I'm just kidding. No, but I've sold like way more keyboards than I could possibly imagine to people in Japan, which is crazy to me, because I'm just some guy in Milwaukee that has hand pain that tried to solve a problem for himself. And I think of Japan as kind of like the creme de la creme as far as like tech and just things of beauty. So like the fact that the keyboard's kind of taking off there is like, it's crazy to me. But that's effectively it for this. Like, the stuff from here on out is the boring stuff, which is just like, watch me do a bunch of hot swap solder joints. And I've done that on a bunch of live streams already, so I'm going to spare everybody the details. The one thing that I hadn't done, which pops up a lot, and all of my support requests are effectively, this side is dead, this key is dead, and you know, when I look at the MCU or when I look at the joints, they're either way too hot, and I mean way too hot, or way too cold, or just, you know, like most of the time it's just cooking stuff. So if you have an iron, to recap, get yourself a good iron. Make sure that you're following the temperature that is recommended by the soldering manufacturer that you're selecting. You know, in regards to soldering, get a good solder. These are electronic components. You're not soldering, you know, 12 gauge, 14 gauge automotive. This is a lot more sensitive. You can't just hold heat in one area for a long time. And yeah, hopefully that helps some of you guys, because I know the documentation isn't all that wonderful on crosses, and it is not exactly what I would call like a beginner keyboard. But you know, I'm really happy to help you guys. But I've ran into a lot of the same issues with support, and it's always just cooking pins, cooking MCUs, and cooking boards, and or bad joints. And I think that's okay, but hopefully this is just kind of like one of those, like, it's like you can watch this. I'm always happy to help people on support, but the bench testing step is super crucial for the build. Because the nice part is that, like, we are building upon a truth. We know that the keyboard works. We've tested the matrix. I don't need to test these with PCBA unless you were crazy with the heat in the MCU. These thumbs are going to work. You know, the only gotchas really are the stuff that's like a little bit, like, it has a more complicated route to get there. So like this goes into MCU, goes over FPC connector, comes into another FPC connector, branches out over here. So that's a more complex relationship as far as like connection. And then this is like host, MCU, data pin, over the data pin, into the USB here, into the data pin on this MCU, and then out of one of the column pins or row pins or I2C pins, out to either, you know, a JST SH connector to the trackball, or a FPC 15 pin, 16 pin connector over here. So this is the most complicated jump right here. Host, MCU, data pin, USB cable, data pin, MCU, column or row pin, jump to FPC, FPC, and then matrix. This is the most difficult journey for the keyboard. But as you saw, we bench tested that kind of stuff, and it's real. Like, there's not a lot of complexity as far as assembling the keyboard. I just really don't like having to tear it apart to diagnose an electrical issue. So I like diagnosing electrical issues while it's still all like this. It just makes it quicker to move stuff around and look at the underneath. You know, like, I'm not removing 4 fasteners to flip this upside down. I'm not worried. It's not tucked into a case, so I'm not worried about like ripping a cord out or anything like that. Just makes it a lot easier. So yeah, that is the bench test assembly for a crosses or bridges keyboard. This is a 42. The only difference between a 42, a 36, and a 54 is the size of the matrix. That's it. Yeah, thank you guys. And thanks for attending my first stream on YouTube. I have no idea what I'm doing, but I'm having a good time.